done the first half of this when we worked with polynomials back in whatever. So what we did in the past is that we were given 3 intercepts for a cubic at another point, and you figured out what A was and rewrote the function. You've done this. The second half of this section is the new stuff. So I'm just going to kind of remind you of how you use a cubic function model to rewrite it out. Cubic function means there's a 3rd degree polynomial, which has at most 2 changes of direction.
All those things? Okay.
Yeah. So if you look at this problem here, it's giving you a graph of a cubic function, which means it's a 3rd degree polynomial. That also shows you that it has 3 zeros and 1 other point. Your zeros are located where?
On the x-axis.
Very good. More specifically, what are their? Let me rephrase that. Your zeros on the x-axis have a value of what? So your terms will be
X plus 3, X
Everybody okay with that? Same thing we do with the quadratic model. If you're given zeros, you knew what your terms were. Okay. Now the other part of this is that y has to equal a times all of that. Remember, f of x and y equals are synonymous with one another in this case. What's the other point? What do you think you're going to do with that negative 2?
Look at the x and y.
Substitute it.
Substitute, that would work too.
Substitute is more syllables. No, it isn't. I don't know. I can't count really.
So once again, you have to worry about some subtraction and multiplication. Shouldn't be that scary.
I can't add that fast, Katie.
So what's A? Good. And just like you did yesterday, you're just going to rewrite out the model with all of those intercepts. So your answer for this equation would be y equals 1/5 times x plus 3, x plus 1, and x minus 3. And remember, it doesn't matter the order in which you put your terms in. It all means the same thing. And you're done.
Wait, there's more.
No.
Oh, there's not.
Well, there's another thing we're going to do, but for this, that's all there is. Okay?
Are there other
Now-
ways to write cubic functions? 'Cause
What's that?
Are there other ways to write cubic functions? Gosh dang it.
The other way to do these things is if you don't know zeros.
It's finite.
Finite.
It's finite. It's the opposite of infinite.
Finite.
So
It stops. So what happens here is that we talked a little bit about this before when we were looking at the graphs of these. When we knew if something was quadratic, it had at most 1 change in direction. It had that 1 hoop. If it was a 3rd degree polynomial, it could have 2 changes of direction. 4th degree could have up to 3 changes of direction, but sometimes it only had 1 change. All those types of things happen. That's kind of what we were basing our information off of earlier in the year. Well, now, the twist to it. To come up with a true model of knowing what the equation is going to look like, you have to do this one very simple step. It's called finding finite differences. What is differences in math? Subtraction. So you have to know how to subtract a few times. Now, you're given here 6 terms of some function, 1 through 6. That means f of 1 is -1, f of 2 is 3, f of 3 is 3, and so on. Okay? What we're going to do is we're going to find the differences between each consecutive set of f of x's, working from right to left. What's 3 minus -1?
Is this like the opposite for the 90
This,
days?
this is f of 1 equals negative 1. F of 2 is 3. We don't know what the equation is yet. We're going to find the equation. And this is how we do it. By using these finite differences, it allows you to tell the degree of the function. Therefore, you'll be able to know which stat button to press when you calculate. Oops. When you hit the calculate button under stat, you have linear, quadratic, cubic, and quartic. Whether it's first degree, second, third, or fourth degree polynomial. By doing this process, you'll know which one to press. So what's 3 minus 3? What's 5 minus 3? What's 15 minus 5? And 39 minus 15. Are those numbers the same? Subtracting the
In the matrix now.
3 minus negative 1, 3 minus 3, 5 minus 3, and so on. Are those numbers the same? No. Do it again. What's 0 minus 4? No. What is 2 minus 0?
2,
10 minus 2.
8.
Yes, I'm sorry. I'm going the other way. And then 24 minus 10. Are those numbers the same? No, so what do? We do it again. What is 2 minus negative 4?
666, coincidence? I think not.
Gee, I haven't heard that one at all today.
That's pretty good.
Are those numbers the same? Yes. So these numbers are all the same, which means all you have to do now is count the number of times you had to subtract. 1, 2, 3, which means what's the degree of the polynomial? So it's a third degree polynomial. So this is your L1, this is your L2, and you find the cubic model. Done. Yeah.
The list.
That's all it is. Now you use your lists to, by figuring this out, it allows you to tell the degree of the polynomial by how many times you had to subtract to get all the same value. On your calculator, the one button you've been pressing for the past few days. Okay? That's how this works. Do I need to go through the L1, L2 process again?
Wait, but what is the third
How many times did you subtract? Okay, that means that this is a third degree polynomial, which means you're going to, if it's a third degree polynomial, on your list, when you have to find your regression, you're going to choose cubic regression. It tells you which one to choose. Yes, Ken? I don't want to ask you that. All right? Same idea. Do the same process. We're going to find the finite differences. What it means by finite differences, when do you stop finding differences? When they're the same. That's where the finite differences comes in. Okay? So we have one, again, all these are going to set up the same way. 1, 2, 3, 4, 5, and 6. And it's just a matter of finding your subtraction. Always go right to left, right to left, right to left as you're going through these, okay? And it's perfectly fine to get negative values. Be careful when you're subtracting with negatives. I screw it up all the time, so just go slowly. $15 minus 6. 22 minus 15. 21 minus 22. 6 minus 21.
Yeah.
And then negative 29 minus 6. Are those the same?
No.
So what do?
Subtract again.
We subtract again.
And they're not going to use it.
7 minus 9.
Negative.
1. Negative 1 minus 7.
For sure.
Negative 15 minus negative 1. And? Are those the same? No. So what do you do?
Subtract again.
What do you get? What do you get? And what do you get? Are those the same?
You know what? I think capture thermostat. I've seen it, but this is a little too much for me.
How many times did you have to subtract? What's the degree of the polynomial? You have a third degree polynomial. So as you go back into your list,
Don't they need to know the homework?
I'm sure somebody text them or.
I'll write it on the
I'm not
board.
going to tell any of them.
I'll write it on the board.
I won't tell.
After school.
I already have my L1 set from 1 through 6. My f of x, which is my L2, will be 6, 15, 22, 21. I forgot the next one. 6. I could have done that too, I guess. And not that I didn't trust you. So my two lists are set, ready to roll. I go back to my stat, calculate, and which one do I choose? Cubic. It's another 6.
I'm very uncomfortable.
So now, here's your A, B, C, and D for filling out your equation.
Lincoln, you should be like this.
So you have negative 1x cubed plus 5x squared plus x and plus 1. And there's your answer.
Is there a way to solve without a calculator? So is it
I wouldn't want to do it without it. I would. When you go through that, you would have to plot a scatter plot, and then assume you know how to write a cubic model by hand. And good luck with that. Not to say that you couldn't do it, but questions?
No, I'm capturing.
Why?
I'm trapping your Satan board.
What's wrong with my Satan board?
I'm immortalizing it.
Is that not a good plan? That sounds like a bad plan.
Okay. So this is section.
See, told you.
Oh, that was fast.
What is this 384?
I got a 5 out of 10 on it. That's okay.
There's like, it was dead silent. It's like, you guys just stop talking. And then she's like,
So I was there when he explained it, and I did more of a soap carving.
so made we were supposed to do
Like a sculpture, you take away, you don't really scratch it. Does that make sense?
The word problem size of this stuff you've already done. We'll just kind of revisit real quick tomorrow. I might try and throw a more complicated polynomial one at you. I don't know.
Not like a quiz, is there?
Wait, no. Somebody did though. I think I feel like
It's the last one.
It probably was.
I'm not even, and that's the only thing that
no, that's the wrong answer. That's what it was. I know somebody's
That's
worse.
for me.
Does anybody have to know soccer?
I don't know. I don't think we have a
4 to 2.
Oh,